Hi chemists, welcome to the next video in the hydrocarbon series. We're looking at structural isomers. Finally, syllabus point on the top left hand side. Explore and distinguish between different types of structural isomers, including saturated and unsaturated hydrocarbons, including chain isomers and positional isomers. So two different types of structural isomers that we're going to look at, and we need to look at them with double and single bonds. That's what the saturated and unsaturated is going on about. So, remember, isomers have the same molecular formula, they've just rearranged in different ways. So, two types of structural isomers are position isomers and chain isomers. We're going to look at those. And first up, I'm going to talk about position isomers. So, position isomers have the same carbon chain backbone. The carbon chain backbone doesn't change, but they have their substituents or double or triple bonds in different positions. So, double bonds or triple bonds in different positions along the backbone, or if there's methyl or ethyl branches, or if there's like bromines or halogens on there too in different positions. Same carbon backbone, chain positions for those substituents, we've got a positional isomer. On the left-hand side, I've given an example of one. C4H8 is either but1-ene or but2-ene. We've got two isomers, and they're positional isomers because in the left, the but1-ene, the double bond is in the 1 position, and in the other isomer, it's in the 2 position. So there's two positional isomers of butene, but1-ene or but2-ene. There's no but3-ene because but3-ene is just but1-ene and you're on the other side of the page. Okay, or you're just numbering it from the other side too. So they have the same carbon backbone, it's just the double bond is shifted, so we've got a positional isomer. Let's look at some more examples. And I have noticed that I have done one wrong, so I'm going to highlight and hopefully come back to that. But we can talk through it. So, up here we've got two different types of two isomers of chloropropane. Well, we would if I did it correctly. So, they both have the same molecular formula, C3H7Cl. Okay, here we've got chlorine in the 1 position, and here, once I've done my scribble and fixed that up, we've got chlorine in the 2 position. Okay? I obviously just copy-pasted that. Okay. So, two positional isomers. Here we've just shifted the position of the chlorine from the 1 to the 2. Or we could have shifted it to the 3, but that is just one chloropropane counting from the other side or looking from the other side of the page. Okay, so there is two positional isomers. One other thing that I just want to say here too is the C3H7Cl, I can tell that it's got an alkane backbone because remember that a halogen will just have a single bond, so it's essentially like replacing a hydrogen in the formula. So C3H7Cl is going to have the same kind of formula as C3H8. Same kind of structure. That fits the 2n+2 rule. So that's telling me it's a halo alkane with the chlorine on there. It's telling me that it's saturated. Just a little side note there. Okay, here we've got some positional isomers of a dibromoethane. Okay, we can either have the bromos on the same carbon or on opposite carbons, okay? Yeah, if we shift that over, they're on the same side. If we shift that over, it's not another isomer, they're just on the same side there. So there's two positional isomers of dibromoethane. There's 1,2-dibromoethane and there's 1,1-dibromoethane. Notice there's not 2,2-dibromoethane because that's just 1,1 seen from behind. Okay. This example down here, a little bit more complex. Okay, what have we got going on here? We've got a double bond that is shifting along the backbone, and we've also got a fluorine that's shifting along the backbone. Oh, not just one fluorine. Oh, well, there's one fluorine here that could shift, but it doesn't. So we've got a formula for both of them, C5H8F2. So we've got a difluoropentene, and we've got two positional isomers of it. There could be many more here, but I'm just showing you two. I've got 4,5-difluoropentuene, and I've got 2,5-difluoropentuene. So I've shifted a fluorine along, and I've shifted the double bond. Note that as soon as I get more substituents, there's more different ways you can arrange them. It becomes more and more complex, okay? More substituents, way more different isomers. So there's three examples of position isomers. Let's talk about chain isomers. So chain isomers do not have the same carbon backbone, but the backbone is shortened and the carbons that were there are now side branches. Okay, so for C5H12, we have got a saturated alkane because it fits the 2n plus 2 rule. 12 is 2 times 5 plus 2. Okay, so the most obvious structure of that is pentane, just a straight chain with 5 there. But we've also got chain isomers. So what you do with the chain isomer is you go, well, I'm going to take the chain length down with one and put a methyl branch somewhere. Do I get another isomer? Okay. Here, so we're taking the main branch down to 4, and we can see that we can put a methyl branch in the 2 position. We can't put it in the 3 position because that's the same as the 2 position. So we do have a methyl butane. Notice, because you can't put it, because you can only put it in one spot on that 2, you can't put it on the 3 because it's the same as the 2, and you can't put it back on the end because it's no longer a butane. You don't need to put a number in front of methyl butane. There's only one methyl butane. There's no positional isomers of methyl butane, so you don't need to number it. There's also another isomer where we shorten the chain again to 3. And because we're taking 3 away, we can put on an ethyl or 2 methyls. If we put on an ethyl, though, we're just getting back to a butane. Okay, but there is one possible way where we can add 2 methyl groups to a propane background, and they are in the 2 positions, okay? Because if they were in the 1 or the 3, then you're just lengthening the branch, okay? So the name for this molecule is dimethylpropane. Notice again, I don't need to put any numbers, because there's only one possible dimethylpropane. You can't put them anywhere else apart from the 2 position. So I don't need to put the 2 there. It's redundant, and I could get marked down for those redundant 2s there. So just dimethylpropane for that molecule. So that's how chain isomers work. Shorten the backbone and put on methyl and ethyl branches and see if you get a new molecule. You might not always get a new molecule. You might just be getting back to a longer chain though. So watch out. Okay, examples. Draw all the position isomers of 1,1-difluorobutane. Okay. Butane. 1, 2, 3, 4. Meth F prop but. Okay. And we've got, in the 1 position, 2 fluoros. Oh. Okay. What I do here with these questions is I know that all the rest of it's saturated with hydrogens, so I don't draw them in yet, okay? I leave it right until the end. It's a bit cheating, but you can see what's going on easier. So we've got 1,1-difluorobutane. What we can do is just do, because it's a position, we've got to keep the backbone the same, okay? So I'm going to put a few backbones out and see what rearranging I can do before I start to get all these ones that are the same, okay? I know I can put a fluorine on 1 and the 2, okay? I know I can put the fluorine on 1 and the 3, and I know I can put 1 on the 4, and they're all separate. So I've got 4 there at least. Okay. What else can I do? I can put the 2 and the 3. And that's a separate one, isn't it? Okay. I'm starting to scrounge a little bit, but I'm sure there's more, maybe one or two more. I've just got to consider them. So I've got the 2, 3 there. Ah, they're doubling up. I can have 2 of them on the 2 position. I haven't got that so far, have I? Okay. Ah, can I have 2 of them on the 3 position? Well, no, that's the same as this one here, 2 of them on the 2 position seen from behind. And if I put 2 on the 4, that's the same as this number 1 here. Okay, so I've exhausted that option. Have I got any more? I think I might have reached the limit. 1 on the 1, 1 on the 3, 1 on the 1, 1 on the 2, 2, 2, 2. I think I might have it. All the positional. That's the only kind of changes that I can make where the fluorines are. I think I've got them all. It would be embarrassing if I missed them one. Yeah, I'm just checking over my work. Okay. Now what I can do is, because it says draw them all, I better put the hydrogens in, okay? So just bear with me. Don't leave them out in your exam answer because you don't want to lose marks for doing something so silly. Okay. There's a hydrogen there and a hydrogen there. Oh, this is going to be messy because I've drawn them big and squished them all in. But you can see how easy it is if you just leave out the hydrogens from the start. Oh, this is quite boring, saturating the molecules, isn't it? I wonder how your weekend's going if you're doing this on the weekend. I'm doing this on the weekend. Maybe I should talk about the historical basis of this time with COVID-19. How long is this video going to stick around and will anyone watch it anyway? Doesn't matter. I'm just rambling. But if you know me, I can ramble. I think I've got them, but doesn't mean it's neat at all. Okay, so I've got 1, 2, 3, 4, 5, 6 different isomers. If I've missed one out, leave a comment. I will be mildly embarrassed, but very thankful. Example 2, how many chain isomers does hexane have? Ooh, chain isomers. So we're shortening the branches. Okay. Let's just draw our hexane as a start. Oh, that's only pentane. Okay. So what I can do is, it has 6 carbons long because it's hexane. Let's see how many isomers we can get. Chain isomers with a 5 backbone. 1, 2, 3, 4. I need one more. So I can put a methyl branch somewhere. I can't put it on the end because then it just goes back to hexane. So I could put one there. Okay, 1, 2, 3, 4, 5. I can put one in the middle. Okay. I can't put one second from the other end because it becomes the same as this second one I've drawn, and I can't put it on either end there. So I've exhausted the isomers of our pentanes, okay? So I've got 2-methylpentane or 3-methylpentane. Okay, let's shorten it yet again. 1, 2, 3, 4. Now I've got 2 carbons to play around with. Okay. Notice one thing that I can't do is I can't put an ethyl branch here because suddenly that becomes the longest one and I've got this molecule directly above it. Can't do that. Won't give me a new molecule. So I can't put an ethyl branch on the end and I can't put a second from the end, so I can't do ethyls. Can I do a methyl? Okay, I can't put a methyl on the end, but I can put a methyl there and a methyl there. And I've got a new molecule. And I can put a methyl there and a methyl there. And I've got a new molecule too. So there's our 2 butanes. So this one here is 2,2-dimethylbutane. And this one here is 2,3-dimethylbutane. Yeah, I'm pretty sure they're the only options there. Now let's see if we can do one with a 3 on there. I don't believe it's going to be possible because I've got to put 3 on there. That means I've got to have a methyl and an ethyl branch coming off. Oh, look. Now I've got a butane. So I can't do one with 3 wide. So I think I've found all my options here. I've worked through them systematically. How many chain isomers? 1, 2, 3, 4, 5. 5 chain isomers. I made a rookie mistake. I drew the hexane on the top. It's only 4. 4 chain isomers of hexane. We've got the 2-methylpentane, 3-methylpentane, and then there's 2,2-dimethylbutane and 2,3-dimethylbutane. Okay, another example. Here we've got halogens in there. We've got 2 different halogens. Okay. C4H8BrCl. That's kind of like C4H10. That's an alkane with 4 carbons long. Oh, draw the structures of and name all isomers. So we've got to do chain and positional. I better draw really small. Okay, this is more pressure. Okay, so we've got, I'm going to draw the original one. Hopefully I don't count it as an isomer. Oh, well, it hasn't given me one here, so we're counting all of them. Okay, so C4H8, bromine and chlorine. I'm going to leave out the H8, and I'm just going to shift around the bromines and chlorines on these backbones to do positional ones first, okay? Positional ones where it's 4 long. I'm going to get a few ready. Just a few backbones ready. I'm probably cramming them too close, aren't I? Okay. Why not? Change colours. Bromine and chlorine on the number 1. Bromine, chlorine, can't talk. Chlorine on the 2. Chlorine on the 3. Chlorine on the 4. Okay. Let's put bromine on the 2. Oh, this is going to be too long and convoluted, isn't it? This is a horrible question. There's going to be too many. Draw all the structures and name. I didn't think about this before I put it in, did I? This is terrible. Okay, I'm just going to have to stick with it. Keep going. If you get one like this in an exam, though, whew, you can see how many options there are. Okay, so bromine in the 2, chlorine on the 1. Bromine on the 2, chlorine on the 2. Okay. I set myself up for the worst traps, don't I? Have I got bromine on the 3, chlorine? Bromine on the 2 and chlorine on the end? Yeah. Okay. This is ridiculous, isn't it? Oh, you're not going to get a question like this. Let's see how far I can go. Bromine on the 3, though, I don't need to consider those because it's like bromine on the 2. So that's good. So it's not as bad as what I thought. Okay. Did I do bromine on the 2, chlorine on the 3rd? I didn't. All right. There's probably way more. Well, there might not be. I'm just mumbling to myself while I'm thinking. You're probably all yelling out at me and pointing at one and going, "That's wrong," or "Why not this?" This is the trouble, what you're going to have to deal with in an exam. But if they give you a problem like this, maybe they'll only give you an example with with 3 carbons. That would be fairer. Okay. There's a few positional isomers, isn't there? Okay. Chain isomers. Well, chain isomers are all going to be based on this, okay? A methyl, I was going to say pentane, a methylpropane. Okay, so they're all going to be methylpropanes, but with the bromine and the chlorine in different positions. So on the end, one on opposite ends, one in the middle, the opposite of that, and then 2 in the middle. Oh, can we do that? No, we can't do that. We can't have 2 in the middle because then that carbon will have 5 bonds. Have I got all the options? 1 on the outer carbon, 1 on the opposites. Oh, 1 on it, 1 on that. I think I've got them all. Again, you're probably yelling out at me something that I can't obviously see. Okay. I'm going to call it. There's probably something that I've missed, but let's call it. I'm not going to write all the names down, but I'm going to start with, I'm going to highlight as I go along. This one here, it's a 1-bromo, 1-chloro-butane. This one here is a 1-bromo, 2-chloro-butane. This one here, 1-bromo, 3-chloro-butane. 1-bromo, 4-chloro-butane. 2-bromo, 3-chloro-butane. 2-bromo, 1-chloro-butane. B before C. Notice I'm keeping that consistent. 2-bromo, 2-chloro-butane. 2-bromo, 4-chloro-butane. 2-bromo, 3-chloro-butane. Ah, that's the same. Oh, that's probably what you've been yelling out to me. That's the same. Cross it out. This is why you check what you're doing. All right, then we're going for our chain positionals. We have, what would go first? B, C, M for methyl. Okay, so we've got 1-bromo, 1-chloro, 2-methyl propane. Okay. 1-bromo, 3-chloro, 2-methyl propane. 1-bromo, 2-chloro, 2-methyl propane. 2-bromo, 1-chloro, 2-methyl propane. I think I've got them all. Watch me regret saying that. Anyway, that's our last example. It was a bit of a tough one. I can't imagine you getting one that hard in the HSC. Okay, got Ed Rollo there on structural isomers. And then I'm going to start talking about different structures and a little bit of miscellaneous stuff. But thanks for joining me on that video and watching me squirm.